going on, everybody? Johnny Ben here at Trepa Technologies. In today's video, we're going to go over domain 4.2 in our free full Network Plus video series. So like, subscribe, share with your friends, hit that bell if you enjoy the content, and let's go ahead and dive right into it. So I'm going to get my face zoomed out here. Let's go ahead and do it. So we're going to be going over domain 4.2, summarize various types of attacks and their impact to the network. This is just basic network attacks. We're not going to lab it up, not deep dive into it. I just want to give you a general overview of what the attacks are, maybe some mitigation, but you just got to know overall, okay, this is what a DDoS may look like, and this is what it does, right? We're going to go over VLAN hopping, MAC flooding, ARP poisoning and spoofing, DNS poisoning and spoofing, and then also go over rogue devices. Okay, so we're going to be going over the objectives on the left in this video. Next video, we'll go over the objectives on the right. Okay. So first, let's talk about DOS or DDoS, denial of service or distributed denial of service. So DOS and DDoS attacks are malicious attempts to disrupt the normal functioning of a targeted server, service, or network. So imagine this is us trying to overcome API rate limiting. So us just sending API requests after API requests, trying to take down that API or, make it so that it can't accept legitimate requests. Think of this as SYN flooding. So in the TCP three-way handshake, the first flag we send when starting our TCP data transmission is a SYN flag. And then we're supposed to get a SYN ACK back. Where a SYN flood attack is where we send thousands, tens, hundreds of thousands of SYN flags without ever getting acknowledgments back and establishing the data channel, right? So DDoS or DOS is typically done by botnets. So when we talk about here a botnet, what is it? So it starts with a CNC, a command and control. And then we get hundreds, thousands of bots. We infect people's computers, devices, take up just portions of their compute and network resources, and then all at once, from our command and control, we can use the thousands, tens of thousands of infected devices to commit some of these DDoS or DOS attacks, like that SYN flood attack. So common techniques: flooding a server with excessive traffic, exploiting vulnerabilities in the target system. So DDoS attacks can paralyze large organizations, causing significant financial losses and reputational damage. Protections, really just getting into high availability, right? Having load balancing, having, stacking servers or clustering servers, having CDNs, having caches, having the high availability, having rate limiting on the API that says, whoa, if we notice this is happening, let's cut it off, right? VLAN hopping. So VLAN hopping is a network attack that allows an attacker to gain unauthorized access to traffic on a VLAN. This exploits vulnerabilities in network configurations. So types. Really VLAN hopping, it occurs when an attacker sends packets to another VLAN without proper authorization, effectively bypassing VLAN security measures. So types, we have switch spoofing. So this is when an attacker tricks a switch into thinking their device is another switch. We can typically do this by manipulating maybe some of the dynamic trunking protocol, where we tag our Ethernet frame in a way that says, hey, I'm actually a switch, let's form a trunk. And then we can bypass us getting into another VLAN's network, right? Double tagging. So this is when an attacker sends a packet with two VLAN tags. So a VLAN tag, when using the 802.1q standard, is a 4-byte header that says, hey, I'm part of this VLAN. So let's say we do double tagging where we put, hey, I'm a part of this VLAN. When we do that, that first tag is stripped off by the switch. Then the second tag allows the packet to be forwarded to the target VLAN. So risk, unauthorized access to sensitive data across VLANs. So let's say we're trying to get access to the research and development department. They're in VLAN 500. Well, I can't just walk into that area, plug my computer up to that wall jack. Maybe, I don't have the right settings on there. Maybe we're doing 802.1x. Or maybe it's just as simple as that's where VLAN 500 is, just on that little 24-port switch that's in a comms closet that just services the research and development department. So I do a double tagging attack that allows me to get access to VLAN 500 and then access resources as a part of that network that otherwise should be private and confidential. MAC flooding. So this is affecting the MAC address table or the content addressable memory table in a switch, which is very vulnerable to something like a MAC flooding attack because the MAC address table is usually run by CPU, and CPU in a switch isn't very powerful because typically we have ASIC chips sitting at the actual interfaces that are doing most of that compute processing rather than a CPU. This is achieved by a user just flooding that MAC address table with thousands or millions of MAC addresses that then the switch CPU tries to process in the MAC address table. We can prevent this by doing something like port security. So definition, MAC flooding involves sending a large number of frames with different source MAC addresses to a switch, filling its MAC address table. And then when it's full, legitimate traffic can no longer be switched within the environment. ARP poisoning, so the address resolution protocol. This maps layer 3 to layer 2. What we mean by this is, imagine we set a static IP on host 1 here. We give it a default gateway, subnet mask, and IP address. But to actually build our entire network packet to talk outside of our network or to talk to the default gateway, we need layer 2 header. That layer 2 header needs a destination MAC address that's going to be forwarded to our default gateway. Well, that's not something that we statically set. So what that computer does is sends an ARP request that says, hey, I know the default gateway's IP address, but I need its layer 2 information. So that ARP request is asking for that layer 3 to layer 2 mapping. And if everything goes smoothly without any malicious threat actors in the middle, that default gateway will reply to that it's actually a broadcast, and say, hey, I am that IP address. Here's my MAC address. So it does an ARP reply. And then that host is going to say, awesome, thank you. I'm going to put that in my ARP table. And next time I need to talk to the default gateway or somewhere outside my LAN, when I build that network packet, I now know to insert this MAC address you just told me of the default gateway into that layer 2 header. And that's what our ARP table is there for. Well, ARP poisoning is when an attacker intercepts that and actually replies saying, actually, hey, I'm the default gateway. And you may never notice this because your host says, all right, cool, layer 3 to layer 2 mapping. This is the MAC address, this malicious actor. And now we're sending all of our network traffic to that malicious actor. But then that malicious actor is forwarding you to the internet. So you may never know, but in the middle of that, they're doing packet captures and they're looking at all your information. So the risk, data interception, and essentially a man-in-the-middle attack, right? ARP spoofing. So you may say, well, didn't this last slide say they're the same thing? So it just, these are the definitions the Network Plus exam wants you to know. ARP poisoning is more man-in-the-middle. ARP spoofing is when an attacker sends like a gratuitous ARP to local area network saying, hey, I am the default gateway. That's what a gratuitous ARP message does. It says, hey, I'm the default gateway, right? So then everyone just fills their ARP cache immediately. That's the definition of ARP spoofing here. So ARP spoofing is a type of attack that targets the address resolution protocol in a local area network. This allows an attacker to intercept, modify, or disrupt communications between devices. DNS poisoning. So DNS poisoning, also known as DNS spoofing, is an attack that involves corrupting the domain name system cache, redirecting users to malicious websites instead of legitimate ones. So in our previous, in domain 3.4, we learned about DNSSEC and like actual DNS over TLS. This is what this protects against, a DNS poisoning attack, where it's kind of almost like another on-path attack, where a threat actor intercepts the traffic and sends the client a malicious DNS server IP, and then we can do packet captures on that, or redirects them to a malicious site, and then that site kind of, I like to say cosplays, but the site mimics maybe a legitimate site to try to do credential harvesting, things like that, right? So DNS poisoning occurs when an attacker alters DNS records to associate a legitimate domain name with a fraudulent IP address. This misleads users attempting to access a legitimate website. Rogue devices and services. So rogue devices are any unauthorized devices that connect to the network. So this could be a rogue DHCP server. This could be an evil twin, which we're going to learn about in our next slide, or rogue access point. That there is some differences between rogue access point and evil twin. We'll go over that. That's just any access point that's on the network that you didn't put there. And you're like, hey, this is not right. Most of the time, if you're in a big wireless environment where you have wireless LAN controllers, you're usually monitoring this, right? You're monitoring that RF spectrum, and that wireless LAN controller can say, hey, we see an access point that we don't know, and it'll alert you, okay? So rogue APs create fake networks, tricking users to connect into it, often with similar SSIDs, not the same, that's an evil twin, but an evil twin can be categorized as a rogue access point, just something more specific. But a rogue device, right, is just anything not authorized on the network, that's on the network, that could potentially trick your users. All right, let's go ahead and do our quiz. I'm going to pause the video and let's knock it out. Okay, so let's go ahead and do our quiz for domain 4.2.1. Scroll down here. Let's take this domain quiz. Let me zoom in. So question 1. What is the primary purpose of a MAC flooding attack on a network switch? It's going to be A, to exhaust the switch's MAC address table and force it to broadcast frames. If you want to read the explanation, go ahead and pause the video. Question 2. What is a common impact of a rogue DHCP server on a network? It's going to be A. It provides unauthorized IP addresses that can disrupt network communication. And if you want to read the explanation, you can read it down here. Go ahead and pause the video. Question 3. Which of the following is the most effective reason for disabling unused ports on a network switch? It's going to be B. To prevent unauthorized physical access to the network. Pause the video if you'd like to read the explanation. Question 4. Which of the following is a key difference between DNS poisoning and DNS spoofing? That's going to be B. And we didn't touch on this in the slide, so I'm glad we got to do it here. DNS poisoning modifies a DNS server's cache, while DNS spoofing involves sending fake DNS responses to clients. Pause the video if you'd like to read the explanation. Question 5. Which of the following best describes a distributed denial of service attack? That's also going to be B. An attack that involves multiple sources flooding a target with excess traffic. Pause the video if you'd like to read the explanation. And then last question, is this the last question? We'll see. In which type of attack does an attacker use double tagging to bypass network segmentation and access traffic in a different VLAN? That's a VLAN hopping attack. Go ahead and pause the video if you'd like to read the explanation. Question 7. Which attack type involves associating a malicious MAC address with the IP address of a legitimate device to intercept network traffic? That's going to be C, ARP poisoning. Go ahead and pause the video if you would like to read the explanation. All right, we got 100%. So I want to thank you all for viewing, like, subscribe, share with your friends, hit that bell. And if you want access to our learning management system, get access to our quizzes, exams, flashcards coming soon, click the link in the description below and reach out to our team. Thank you for viewing.